Yeah, hi class, very good evening everyone. Welcome to the session and welcome to this Learn Through PYQ series. Yes, wherein we are going to learn the concepts, okay, like the today's concept, rank of the matrix. Okay, the first I have taken up some concept from engineering mathematics, or rather I would say some important concepts from engineering mathematics. Just a second, let me just check one more thing here. Yeah, okay. So an important concept from engineering mathematics under the linear algebra, that is the rank of the matrix, and we are going to learn this complete concept but with the help of PYQ, so that you also cover PYQs and you also learn the concept of rank of matrix, and you see the variety of questions related to the rank of the matrix that has come up in the gate examinations in the previous years, right? Very good evening everyone. Good evening Sai Vikas. Okay. Good evening, Papa Rao Naik. All right. Yeah, guys. So then let's get started. Let's get moving ahead. Okay. Yeah. Okay. So let's learn through the PYQs, the rank of the matrix. Okay. Let's get started. Okay. With the first question here. Okay. So see, a GATE 2019 W1 mark question. What is the rank of the matrix? Okay. So let's take this question. Then I will define. Okay. Then I'll define what do you mean by the rank of the matrix, and also then we shall understand the different the properties and rules around the rank of the matrix. Correct, dear? All right. Yeah. So let's get started then. Let's get started with this question. Okay. So what is there? Find the rank of this matrix. So now, it's a 3 cross 3 matrix. It's a 3 cross 3 matrix. Correct. Just a second. Why it is? Yeah, correct. So this is what is a 3 cross 3 matrix. Now first, okay, especially if it is a square matrix, okay, let's start with the determinant of the matrix. Okay, what is the determinant of this matrix? Okay, so if I start here with the determinant of the matrix, okay, I'm going to calculate the determinant, and of course if I expand about the first row, okay, of course the first element is 0, okay, 0, and then I start with the next element with minus sign and cross multiply. I hope you are all very clear about the determinant calculation at least. Okay, so then it goes 0 minus 1 and then the plus 1, okay, with 1 minus 0, minus 1 and minus 1 plus 1, so this is equal to 2. Okay, what is the determinant of the matrix is equal to 2. Now when you calculate determinant, understand what you are calculating. Determinant is 2, and especially that determinant value is non-zero. Okay, the determinant value is 2, and not only it is 2, it is equal to non-zero value. Okay, so now what are you calculating here in this determinant? Okay, if I just arrange this as a determinant format, okay, so see what I have done as a determinant format. I have calculated this value 0 1 1 1 0 1 1 1 0. Now every particular matrix will have some minors. Okay, every particular matrix will have some minors. Since it is a 3 cross 3 matrix, what is the largest possible minor? Since it is a 3 cross 3 matrix, okay, what is the largest possible minor? Think about this. What is the largest minor that you can possibly take out from here? What is the largest minor that you can take out from the matrix? The largest minor that you can take out from the matrix, it's itself a 3 cross 3. Okay. Rank is defined as, let's go through the basic definition first. The rank is defined as the largest order of any non-vanishing minor of the matrix. I repeat, the rank is defined as the largest order of any non-vanishing. When I say non-vanishing, I basically mean non-zero. Okay, whether the minor exists, whether it is non-zero or whether it vanishes to 0. Okay, rank is the largest order of any non-zero minor of the matrix. Largest order of non-zero minor of the matrix. Now to support this, okay, I have taken the first example here. See, there is a 3 cross 3 matrix. What is the largest possible minor out of that 3 cross 3 matrix? Is third order minor. Whether it is 0 or non-zero, it is non-zero. It is non-zero, and hence you can say that there is a 3 cross 3 minor which is non-zero. There is a 3 cross 3 minor which is non-zero, and hence I will say that the rank of this particular matrix is 3. and hence I will say that the rank, okay, of the matrix is equal to the 3. 3 cross 3 matrix is third order minor. Whether it is 0 or non-zero, it is non-zero. It is non-zero, and hence you can. Yeah, I think there is a lag in the audio and video. I'll just check it out once. Okay. Yeah. Okay. So the rank of the matrix is equal to 3. So what I just mentioned to you, I have to again send this. Yeah. Okay. So as I just discussed with you, the rank of the matrix is basically the largest order of any non-zero minor of the matrix. Okay. Or you can also say that the rank of the matrix is said to be R. Now see, it depends on books to book. Some of the books will define the rank of the matrix as R. Some of the books may define the rank of the matrix as simply known as rho. Okay. So we here also can write down the rank of the matrix as R of A, right? Or you can write down the rank of the matrix as rho of A, correct? Okay, R of A or rho of A, R of A or rho of A, correct? Some of the books. Just a second, I am just trying to check the audio video settings again. Rho of A, correct? Okay, R of A or rho of A, R of A or rho of A, correct? Some of the books. Okay, yeah. Okay. So if you have at least one non-zero minor of order R, the rank will definitely be said to be 3. If you have at least one non-zero minor of order R. So yes, here I have a third order minor, okay, which is non-zero, and hence the rank is 3. But what happens if this was 0? Here it is non-zero, so better let's take another example. Okay, so let's generalize, more conclusions about rank. Have a look into this example. Then I will talk about some important properties of the rank. Okay, then I shall talk about some important properties of the rank. Okay, so can you look into this question? Okay, old GATE question, GATE 2006, EC 1 mark question. Okay, again a 3 cross 3 matrix, right dear? Again a 3 cross 3 matrix. Once again a 3 cross 3 matrix. Okay, so what is the largest minor? What is the largest minor that can be taken out of here? The largest minor, okay, so minor is always a square determinant. Determinant is automatically square only. Okay, minor is any determinant, any square determinant that you can extract from the matrix. So again, largest minor here that you can extract from the matrix is 3 cross 3. Okay, what is that largest 3 cross 3 minor here? It's 1 1 1, 1 minus 1 0, entire determinant basically 1 1 1. But now you can see that 2 rows of the determinant, either you solve the determinant, okay, but what you can say here, 2 rows of the determinant are exactly the same. And if 2 rows of the determinant are same, okay, or related or identical, which 2 rows? R3 and R1. If 2 rows of the matrix are same or identical, okay, or proportional or dependent to each other, the determinant is always 0. That is one of the fundamental property of the determinant. So what will I say here? Determinant of this matrix is 0. Now think, can the rank of the matrix be equal to 3? Can the rank of the matrix be equal to 3? Rank will be 3 if the matrix has a third order non-zero minor. Okay, so there is the largest minor 3 cross 3, but that is equal to 0. Okay, that particular minor is equal to 0, and because this minor is 0, I can quickly conclude that the rank cannot be 3. Right, I can quickly conclude that the rank of the matrix cannot be 3. Hope that is clear. The rank of the matrix cannot be 3. So what it can be? If it is not 3, let's try the next one. Okay, can the rank be 2? Rank is 2 if you have at least one 2 cross 2 minor which is non-zero. At least one 2 cross 2 minor which is non-zero. Got it? Okay, so first let me randomly try a 2 cross 2 minor here. Okay, I'll separate this minor. What is there? 1 1, 1 minus 1. Okay, what is the value of this minor? See, checking a 2 cross 2 minor, how much time does it take? Few seconds only. Na cross multiply. That's it. What you have to do is a cross multiply. Okay, so I cross multiply, I get the answer minus 1, which is not equal to 0. Answer is minus 2. I don't care. Answer is 0 or non-zero. That's what I care. Answer is non-zero. So I have a 2 cross 2 minor. What? I have a 2 cross 2 minor. Okay, whose value is non-zero, the rank is equal to 2. Okay, the rank of this particular matrix will definitely be equal to 2. Okay, the rank of this matrix will be equal to 2. Okay, so Firstly, I redefine it. Okay, the rank of the matrix, as we discussed, is the largest order of non-zero minor. In the previous case, I had a third order minor which is non-zero. In the previous example, I have a third order minor which is non-zero, so rank equal to 3. In this case, I have a third order minor, okay, which was 0. In this case, the next question, I have a third order minor which is equal to 0, so rank cannot be 3. Rank cannot be 3. So then I checked the 2 cross 2 minor, okay, and that confirmed that the rank is equal to 2. That confirmed that the rank is equal to 2 because I have a 2 cross 2 minor which is 0. Okay, correct na? We'll make some more observations for quick answers. Okay, but let's understand, okay, the definition of rank. Okay, the definition of rank. Okay, so now moving ahead. Okay, if it is a square matrix like 3 cross 3, what is the maximum possible rank? Like 2 examples you have taken for 3 cross 3, what is the maximum possible rank? The maximum possible rank is 3. If the 3 cross 3 minor, which is the entire determinant actually, if the 3 cross 3 minor, which is the entire determinant, if that 3 cross 3 minor itself is non-zero, previous question, the rank will be 3. If that determinant is 0, rank cannot be 3, rank will be below 3. Okay, so what is one of the first observation and the important one? Have a look into this one. Yeah, here it is. Okay, so if you have a square matrix, of size n cross n, okay, if you have a square matrix of the size n cross n, what is the maximum rank of it is equal to n. Like 3 cross 3, maximum rank is 3. Whether it is 3 or below 3, we checked it. But what is the maximum rank I am telling? The maximum rank is equal to 3. So we say that the rank is less than equal to n for a matrix of size n cross n. Okay, but if it is a non-square matrix, okay, if it is a non-square matrix, I will first show you an example. Then we will come back to these points. Okay, we'll come back to these points. Have a look into this particular question. Okay, so some random questions I have taken. Okay, right. Bhargav, I'll introduce row echelon form also. Don't worry, I'll introduce some questions. Ultimate choice will be row echelon, but many questions can be solved by determinant method or what is known as dependency method. I'll talk about the dependent rows and dependent columns. Okay, you just have to wait for it. I'll talk about that as well. Okay, now see, what is the size of this matrix? We'll solve this question after a few minutes, but what is the size of this matrix? The size of this matrix is 3 cross 4, correct? Okay, it has 3 rows and 4 columns. What is the maximum minor that you can pull out of the matrix? So minor is a determinant, a square determinant. Okay, can you take out? Okay, can you take out? See, if I have to just write down what is the largest minor of this matrix. Okay, can you take out a 4 cross 4 minor? How? You cannot take a 4 cross 4 minor. Why? Because do you have 4 rows or 4 columns? No, you do not have 4 rows and 4 columns. So you cannot take out a 4 cross 4 minor. Okay, but what you have 3 rows and 3 columns. Of course, you have additionally one 4th column. Okay, what you can do? Okay, you can erase any one column. Suppose you erase this. What do you get? If you erase this, then you can extract out. Na? Minor is any determinant which can be extracted from the matrix. Okay, so what is the minor I am able to extract from this matrix? 3 cross 3, but not 4 cross 4. Largest minor, 3 cross 3 only. Okay, without calculating the rank, I will come to the rank also. Okay, but without calculating the rank, what should I say? The rank of this matrix, okay, cannot be greater than 3 at least, because the largest minor is 3. Rank is known as the largest order of non-zero minor. Whether it is 0 or non-zero, that is the secondary thing. That is the second step rather, I would say. But what is the largest minor? Third order. So rank can be maximum 3. Okay, or below 3. Got it? 3 or below 3. Okay, so you know, if it is a non-square matrix, okay, whatever, you know, whatever is less in the number of rows or columns, coming back to the point, okay, if you have a non-square matrix of size m cross n, okay, what is the largest minor? Okay, if m is less, you will have m cross n, m cross m. If n is smaller, you will have n cross n minor. So largest minor depends on minimum of mn, and rank cannot be more than that. So what is the rank? Less than equal to minimum of mn. Okay, minimum of mn. Like 3 cross 4, minimum is 3. I've showed you an example. 3 cross 4, minimum is 3. The rank cannot be greater than 3. Okay, rank is 3 or less than 3. Okay. Now, I have shown you 2 cases. Okay, in one of the case, see, both were 3 cross 3 matrix, and for a 3 cross 3 matrix, maximum rank is 3. Okay, in the first question, we got the rank equal to 3, the maximum possible rank. Okay, and in this case, the matrix is said to have what? In this case, the matrix is said to have full rank. In this case, the matrix is said to have full rank. Okay, the matrix is said to have full rank. Clear? If the matrix attains the maximum possible rank, then it is said to have full rank. Then it is said to have full rank. Clear, everybody? Okay, if the matrix gets its maximum possible rank. But in the second question, what happened? In the second question also, there is a 3 cross 3 largest minor. The maximum possible rank could be 3, but it was not 3. Okay, the rank not equal to 3, and I say that the matrix does not have the full rank. Okay, the matrix does not have the full rank. So when the matrix has the maximum possible rank, okay, then it is said to have full rank. Okay, so what is the condition for a square matrix to have full rank? Okay, why in the previous question you did not have full rank? Because the determinant went 0. Okay, if the determinant is non-zero, like our first question, see here, if the determinant is non-zero, for a matrix, for a square matrix, if the determinant is non-zero, it will have the full rank. It's indeed a very important condition, right? It's indeed a very important condition, this fourth one. Okay, so if a square matrix is non-singular, we all know what is the meaning of non-singular. Non-singular means non-zero determinant of matrix having non-zero determinant. So if a square matrix has non-zero determinant, it will have the full rank. Simple, it will have the full rank. If a square matrix has non-zero determinant, it will have the full rank. Okay. Now, coming back to the previous question. The rank was not 3, it was equal to 2. Why? Because the determinant was 0. And see, why the determinant was 0? Because R3 equal to R1. When you say R3 equal to R1, you clearly say that there are dependent rows. Okay. Okay, so how many rows are there? Okay, just understand this point here. Okay, see this. How many rows are actually available here? Okay, there are total 3 rows. Correct? In the matrix, there are 3 rows. But out of the 3 rows, dear, R3 is equal to R1. Whether it is directly R1 or whether it is 2R1 or something like that, it depends on R1. Okay, it depends on R1. I call this as dependent row. Okay, which row is dependent? R3 is a dependent row. So out of 3 rows, 1 row goes dependent. So how many rows will be left as independent rows? R3 goes in the dependent row category. I have 2 independent rows, and here eventually, okay, the rank of the matrix we obtained is also 2, correct? The rank of the matrix obtained is also 2. In many questions, this is going to be a big time savior for you. In many questions, this is going to be a big time savior for you. What is that big time savior? Okay, the dependencies of the rows or columns. It is applicable to columns also. I will show you some questions where columns will be taken. So have a look into it. Very, very important point. Rank of a matrix is equal to what? Is equal to number of linearly independent rows or also equal to number of linearly independent columns of the matrix. Number of linearly independent rows are also equal to the number of linearly independent columns of the matrix. Hope that is clear. Okay. Now, some results that you should straightforward know in many questions, you can use these results. Okay, so I'll give you these results. My idea is not deriving the results right now, but rather taking more and more PYQs. Okay, to help you understand the type of the questions. Correct? Okay, so rank of IN. IN means what? IN means identity matrix. Okay, identity matrix you all know, where the diagonal elements are 1. All diagonal elements are 1, others are 0. Okay, rank of identity matrix will always be n if it is an n cross n identity matrix, because identity matrix has non-zero determinant. The determinant of any identity matrix, the determinant of any identity matrix is always 1, and because the determinant is non-zero, you will have full rank. What is the full rank for n cross n matrix? N. Discuss this point. Let me know any doubts. If you have. Okay. Rank of a null matrix. Null matrix is a matrix where all elements are 0. So whether you take a 4 cross 4, 3 cross 3, 2 cross 2, any minor will be 0 because all elements are 0. Any type of calculation you do will be 0. So rank cannot be 4, 3, 2, 1. The rank cannot even be 1. The rank will be 0 only. Vice versa also. If I tell you that a matrix has rank 0, it can only be a null matrix. Remember that if a matrix has rank 0, it can only be a null matrix, vice versa. Okay. If a matrix is a real matrix, A and A transpose have the same rank. But not only this, the rank of A and A transpose are same, but also equal to the rank of A transpose, also equal to the rank of A transpose A. Also equal to the rank of A transpose, also equal to the rank of A transpose A. I will take a relevant question out of it. I'll explain you this point. Okay. Now, some results mostly, not important for numericals. The rest of the things are important for numericals. These 3 are not important for numericals, but sometimes they may ask as a direct property. Especially in MSQ questions, these patterns are familiar. Okay, so you can note down, or I'll share you this PDF. Don't worry, in the Telegram I'll share you the PDF, so notes will be complete for you. Rank of A into B will be less than equal to minimum of RA and RB. A into B means product of the two matrix. Rank of A plus B will be less than equal to rank A plus rank B. Rank of A minus B will be greater than equal to rank A minus rank B. These are some general results on A plus B, A minus B, and A into B. Okay, with respect to the ranks. Okay, again I repeat, in some other textbooks you may find the rank written as row. I simply use the notation of R. There's nothing in the name, it's all about concept, you know. Okay, rank of a diagonal matrix, we'll encounter questions later. The rank of a diagonal matrix is simply equal to number of non-zero diagonal elements. It is simply equal to the number of non-zero diagonal elements. You can see here, it is simply equal to the number of the non-zero diagonal elements, correct? Okay, next. Okay, suppose sometimes rank of A given and rank of adjoint A asked. Okay, so if the rank of A is n, that is full rank, the rank of adjoint A will also be n, that is full rank. If rank of A is equal to n minus 1, the rank of adjoint A will be 1, and if rank of A less than n minus 1, adjoint A will have 0 rank, because I'll just tell you the last one, important logic in the last one. Okay, rest I'm not deriving as I told you. Okay, so you know, if rank of a matrix is less than n minus 1, not even n minus 1, so what does it mean? All n minus 1 minors, all the minors of the size n minus 1 cross n minus 1 will be 0. And how an adjoint matrix is formed? Adjoint is formed by cofactors. Cofactors are formed by minors. Minors of the size n minus 1. So when I say rank is not even n minus 1, means all n minus 1 minors are 0. Okay, and this also means that, okay, all the minors and hence all the cofactors will be 0, and adjoint is formed by the cofactors. Adjoint of A will be 0. Simple. Okay, adjoint of A will be 0. 0 means null matrix. Okay, adjoint of A itself will be null matrix, and hence the rank will be 0. Okay, yeah. So now moving ahead towards the echelon form. Okay, let's be ready for any type of question, and for some questions echelon form may also be required. Okay, for some questions echelon form may also be required. Let me first take the echelon form, okay, with respect to one of the previous question that is already covered. Okay, one of the previous question already covered. Let us repeat this. The rank of this matrix is 2. How? I have solved. So now we'll have 3 methods here. One, I call it as a determinant method. Simple. Especially square matrix can be easily solved by determinant method, especially up to 3 cross 3. Then second is dependency method, which I told you. The rank is number of independent rows or number of independent columns. Number 3 is the echelon form. Okay, if nothing helps, echelon form. Usually little time taking, but if nothing helps, yes, in some questions I'm telling you echelon form is the only choice. If nothing, no observations or no calculation helps you. Okay, so how do I apply the echelon form to the same matrix? Okay, let us continue here. I'll just copy the same matrix. Okay, so what is the matrix given to us? Okay, the matrix that is given to me is basically, I'll have a look into it. 1 1 1, 1 minus 1 0, and again 1 1 1. Okay, so the matrix is 1 1 1 1. Just a second. Yeah, the matrix given to me is 1 1 1 1 minus 1 0 and another 1 1 1. Correct. This is what is the matrix given to me. Now see, what do you mean by echelon form? Okay, what do you mean by echelon form? Okay, now see, let me define the echelon form and then let's understand with this same example. Here it is. Okay, a matrix, okay, is said to be in echelon form, specifically row echelon form. Okay, we more define in terms of row echelon form. Okay, so a matrix is said to be in row echelon form if 0 rows, if any, by chance if the matrix has a row of 0, okay, it should be at the last. Okay, this first point simply means ROZ at last. By chance if there is ROZ, I don't say row of 0 has to be there. Okay, ROZ if any. Okay, ROZ if any. We will simply call it as ROZ, correct? So if the matrix has any ROZ, okay, it should be at the last. And second point, number of starting zeros in each row must follow a increasing pattern. Number of starting zeros in each row must follow us increasing pattern. Must follow increasing order. Now how? Okay, let's come up here. Let's come up to the same example whose rank is known to us. The rank is equal to 2, determinant and by dependency method. Okay, now, yeah, here is my matrix. Okay, so what will I say? Let us define a term. Okay, let us say m is the number of starting zeros in each row. Let us define m as the number of starting zeros, correct? Okay, so what is m here? Okay, nil. What is m here? Nil, no starting zero. What is m here? Nil. Okay, does it follow increasing order? No. Okay, it is same not allowed. What it is same, and same is not allowed. Okay, it is not in row echelon form. Okay, so I have to increase the number of zeros. See, okay, there is no starting zero here, but here it should be at least one. Then here it should be more than one. We have to follow an increasing pattern. So my first approach will be, okay dear, keep listening, to make this and this zero. At least let us increase 1 1 0 in the next two rows. Okay, 1 1 0 in the next two rows, and this can be done by the elementary row operation. Because we know that elementary row operation does not change the determinant of the matrix, and minor is all about determinant calculation. Okay, so the first step, R2, okay, can be written as R2 minus 2R1. R2 can be written as R2 minus 2R1. Okay, and also R3 will be replaced as, sorry, no, why 2R1? Simply R1. Simply R1, sorry, because I need to make it 0, na? So 1 minus 1. Similarly, R3 minus R1. Just 1 minus 1 will help me and make me 0. Okay, so R2 minus R1, and R3 is also R3 minus R1. Correct, dear? Okay, let's do this operation. Let us do this operation and see what the matrix comes after this. Okay, after this, what is the matrix that is left to me? Okay, so it will be, the first row is not changed, that is 1 1 1. Okay, what about the second row? Okay, 1 minus 1, R2 minus R1, operated on every element. Okay, so 1 minus 1 0, minus 1 minus 1, minus 2 0, minus 1 is minus 1. R3 minus R1 0 0 0. Okay, R3 minus R1, because R3 and R1 were same, na? Okay, so when you subtract, every element becomes 0, and now you again count the number of starting zeros. Okay, what is the number of starting zeros here? Nil. Number of starting zeros, you understand starting zeros, na? Okay, this is what I mean by starting zero. However, how many zeros are there at the beginning of the row? Okay, so how many zeros are there here at the beginning of the row? 1. How many here? 1. Okay, next, how many zeros are here? 1 2 3. Okay, although it is 3, but does it follow increasing? Yes. 0, then 1 is more, and 3 is even more. Does it follow increasing? Yes, that is important. It has to follow increasing. Okay, yes, so it follows increasing order. And you see, there is a row of 0 also. What do you mean by row of 0? A row full of 0. And I told you what? If there is a row of 0, it has to be at the last. If there is a row of 0, it has to be at the last. Perfect? Yes, so there is a row of 0 which is at the last. There is a row of 0 which is at the last. Okay, so row of 0 at the last, and the number of starting zeros are in increasing order. So what can I say? That this particular given matrix is 100% in which form? In the echelon form. Okay, in short, we call it as REF. The matrix is said to be in row echelon form. The matrix is said to be in row echelon form. And then the conclusion. What happens if a matrix is in row echelon form? I just defined the row echelon form with respect to the example. Okay, oh, here the conclusion is missing. Okay, so if a matrix is in row echelon form, if a matrix is in row echelon form, okay, so that conclusion has gone missing here. I'll write down. Okay, if a matrix is in row echelon form, okay, what is the rank of the matrix? Rank of the matrix is simply equal to number of non-zero rows. Okay, for simplicity, I will keep calling non-zero rows as NZR. Correct, na? Okay, if a matrix is in row echelon form, then the rank is simply equal to number of non-zero rows. Rank is simply equal to the number of non-zero rows. Okay, so let's go back to our example. Okay, the matrix is in row echelon form. Okay, I'll write down my answer here. Let me move away for a minute. Now see, the matrix is in row echelon form. Okay, so what is the rank? Writing down the answer. Okay, the rank is equal to number of non-zero rows. NZR, how many rows are non-zero? This is non-zero, this is non-zero, correct na? Okay, so how many rows are non-zero? 2 rows are non-zero. Okay, the rank is 2. Is not the rank equal to 2? See, previous we have done the analysis. What is here? Okay, by the determinant calculation, rank is 2. By the dependent and independent rows method, the rank is 2. This is what is the row echelon form method, echelon method. And there also we have been able to say that the rank of the matrix is equal to 2. Perfect. there also we have been able to say that the rank of the matrix is 2. That's what it is. That is what it is. Okay, hope it is clear to you. Okay, so when the matrix is in row echelon form, okay, it may not be directly in the row echelon form, but if it is in row echelon form, the rank is equal to number of non-zero rows. If it is not directly, you can convert by the elementary row operation, you can convert it to the row echelon form. And now I'll move towards the next question. Okay, let's keep on learning. Let's keep on learning. Okay, more and more with questions. The idea of the session is to learn completely through PYQs, and I will ensure that, okay, rank you can learn through PYQ. Simple. Okay. Of course, we are not deriving into the things, okay, but with the questions, at least if we take up the basic definition and basic property, your topic is complete. Okay. I mean, even if you never studied rank, this session can help you. Okay. So given M, so see, MSQ 1 mark question, GATE 2022 instrumentation branch, MSQ. So MSQ means be careful, one or more than one answer may be correct. Okay. Given this matrix, okay, which of the following statement is or are correct? Given this matrix, which of the following statement is or are correct? Come on. Strange, it may look like a black bottle to you, but it is not a black bottle. It's a green bottle. It's just the chroma and the lightning effect. It's not at all a black bottle. Okay. Chalo, anyways. Okay. Anyways. Naresh says the answer A. Okay. Only A? Maybe. MSQ means one also may be correct, but one or more than one can be correct. One or more than one can be correct. Okay. Anybody? Sai Vikas says BCD. Okay. Sai Vikas says BCD. No, Sai. BCD. All three cannot happen together. Because determinant 0, rank cannot be 3. Na? B and D you are telling together. Okay. See, I have a simple observation, and that is with respect to the third and the first row. Any relation again? Okay. See, 2 into 2, 3 into 2, 6, 7 into 2, 14. Clear relation. Clear relation. R3 is equal to twice of R1. Okay, so what is there? You have one dependent row again. You have one dependent row. Okay, now R2 does not depend. 2 into 3, 6, but 3 into 3, no. So there is no relation between R2 and R1. So R3 is the only dependent row. R3 is the only dependent row. Correct, na? And if R3 is the dependent row, how many independent row? Okay, I can say that you have 2 independent rows. Okay, so rank is how much? Rank is equal to 2. Also, whenever rows are dependent, okay, the determinant is 0. That also you can take. The rank is definitely 2. It's not 3. Okay, next point, rank 3. That is wrong. Okay, are the rows linearly dependent? Yes. Okay, R3 is twice R1. Clearly, I have shown you the rows are linearly dependent. Okay, and the next one, okay, is the determinant 0? Because rank is 2, so determinant has to be 0, na? Okay, because if the determinant was non-zero, rank would have been 3. Correct. So determinant is also 0. So 3 options are correct. All are related. See, MSQ usually does not mean that 3 different points. Usually related points. Usually. Sometimes they create the questions where 3 options means 3, maybe the 3 different calculations required. But yeah, A and D are the correct answer here. Okay. So yeah, Sampath says AD. No, it is ACD. Naresh, correct now. ACD. Sai Vikas, correct. Saurav Kumar, correct. Okay. Some of you are missing C. You are telling only A and D. No, it's ACD. The rows are dependent. Na? The rows are linearly dependent. Okay. The rows are linearly dependent. Correct. It is ACD. Na? Perfect. It is. It is ACD. Next question then. Yeah. GATE 2007 instrumentation 1 mark question. But although some question may be recent, some question may be old, whatever deserves a discussion, I have taken that question. Okay, so let A equal to Aij, where I and j are in the range 1 to n. Okay, 1 less than equal to I comma j less than equal to n, and n is greater than equal to 3. N is 3 or more. Aij is equal to I into j. Then what is the rank of the matrix A? Then what is the rank of the matrix A? Come on. What is the rank of the matrix A? So first, here we'll have to form the matrix A. See, n is greater than equal to 3. Okay, let's try n equal to 3. Okay, let's try with n equal to 3 and let's see if we get any success. Okay, what are the elements? The elements are aij such that aij is I into j. Every element is simply I into j. Naresh has the answer D here. Okay, let's check it out. Every element is I into j. Okay, so what is the matrix going to be formed here? What is the matrix that is going to be formed here? You see here. Okay, the matrix, see, normally if I arrange the element, n equal to 3 means a 3 cross 3 matrix, correct? Okay, so the elements will be a11, a12, a13. The element next will be a21, a22, a23, correct? The next will be 3-1 element, 3-2 element, 3-3. Okay, as per the number of row and column. Aij means ith row and jth column. Okay, so different answers have started coming up. Okay, so now every element aij is I into j. Accordingly, the matrix will be built up. A11 is 1 into 1. A12 is 1 into 2. That is 2. A13 is 1 into 3. Next is 2 into 1, 2. 2 to 4, 2, 3, 6. Next is 3 into 1. Okay, 3 into 2, 6. 3 into 3, 9. Okay, so this is the matrix formed. Now, what about the rank of this matrix? What about the rank of this matrix? Any clear relation between the rows? Okay, you see here, dear, you can observe easily that what is this? This is 1 into 2, 2, 2 into 2, 4, 3 into 2, 6. Okay, that means very clearly R2 is twice R1, correct? Then you see the first and third, 1 into 3, 2 into 3, 3 into 3. What is that? 3 times. Okay, so R3 is 3 times R1. So both R2 and R3 are dependent. Both the R3 and R3 are dependent. Okay, so how many dependency this times? 2 dependent rows. But I want independent row. How many independent? If out of 3, 2 rows are, you say dependent, R2 and R3 are both dependent on R1. So how many independent row? 1 independent row. And rank is equal to number of independent row. It is fixed at 1. It will not depend on n actually. The rank is 1. The rank is 1. Correct answer is B. Yes, Saurav Kumar, Sai Vikas, Ganesh Verma. Correct answer. It is B. It is B, the correct answer. Okay, fine. Okay. Next question. Yeah, so this is the non-square matrix actually. Okay, which I hinted you earlier. Okay, so of course for non-square matrix you cannot try the determinant, but what you can see, dependency, and what else you can see? If dependency also you are not able to figure out, okay, you can think about echelon form. Echelon form, 2 things I have told you. You can think about echelon form. What is there? Any one of them you can think. Let's do it. Okay, now see, dependency is, the dependency may be in rows, may be in columns. Okay, the first, if you want to talk about the dependency, I'll show you some clear-cut dependency here. Okay, let me call this as method number 1. Now you see the numbers. Okay, you see these numbers itself. Okay, the first and second column. Okay, 2 into 2 is 4, 3 into 2 is 6, 1 into 2 is 2. Okay, so yes. Okay, the column, I'll say column number C1 is twice of column number C2, correct? That is my first observation. That is my first observation. Next one. Okay, what is next one? Now you see, you add 2 plus 1, you get 3. You add 3 plus 4, you get 7. You add 1 plus 0, you get 1. Okay, that means even the column 4 can be written as column number 2 plus column number 3. Column number 2 plus column number 3, correct? C2 plus C3. C4 is equal to the C2 plus C3. Correct now? Yes, Sai, because there is a dependency in the column. Okay. So now how many dependency in column? Out of 4 columns. Remember, columns are 4. Okay. And out of the 4 columns, you have figured out 2 dependencies. 2 dependent columns. Okay. So automatically out of 4, you have to count. So 2 independent columns. And if you say 2 independent columns, what will I say? I will say that the rank of the matrix is equal to 2, and that's what is your answer as well. The rank of the matrix is 2, and that is my answer. That is my answer. Perfect. The rank is 2. Correct. Naresh, correct. Sai Vikas, correct. The rank is equal to 2. Now see, dependency is a game of numbers. If it quickly, see, If you are following the dependency method, you save time, but I'll tell you, try the dependency maybe up to some 30 seconds or so. Don't spend a few minutes only finding dependency, because maybe there is no dependency. What will you do? Then you are just wasting time. Maybe there is no dependency. So if you are able to figure out easy numbers in 30-40 seconds, try it. Otherwise, row echelon form, because it's a non-square matrix anyways, you can't take the determinant, na? Okay, so I'll just one more time explain you the row echelon form with this question. Correct. Once again, I'll explain you the row echelon form with this question also, so that the method also is repeated for us. Okay. Let's come here. Okay, so let me see what is the matrix given to me. Just a second. What is that matrix? 4, 2, 1, 3. Four, two. Just a second here. 4, 2, 1, 3. Okay, 6, 3, 4, 7, and then what else is there? Okay, 2, 1, 0, 1. Two, 1, 0, 1. Correct. This is what has been given to me. Okay. Okay. So now, is this an echelon form? No. The number of starting zeros are not there. Starting zeros must be increasing order. It is 0, 0, 0 right now. So what will I do? I will apply the first transformation, and the first elementary transformation that I will apply is, just a second, the first elementary transformation that I am going to apply is the R2. Okay, now see, this is 6. I have to make it as 0. The above one is 4. So into 1.5 will help. 4 into 1.5 is 6. So R2 minus 1.5 R1. Okay, only thing is, whatever you apply has to be applied to entire row, not to a single element. Correct? Okay, so R2 minus 1.5 R1. Okay, R2 minus, and similarly R3. Okay, R3 should be written as R3 minus, now above one is 4. Okay, 4 by 2 will be 2. Okay, so R1 by 2. Okay, or 0.5 R1. Anything you can say. Okay, so by doing this, what is the matrix you are going to get? Let us see. What is the matrix I get by doing this? Okay, first row is not disturbed. It is 4, 2, 1 and 3. Okay, then I have, okay, R2 minus 1.5 R1. Okay, so this is 0. Okay, 3 minus 2 into 1.5 is also 3. So subtraction 0. 4 minus 1.5. Okay, so 2.5. Okay, and 7 minus 3 into 1.5 should be 4.5. So this also will be 7 minus 4.5 is again 2.5. Now last, R3 minus R1 by 2. So this is 0. 1 minus 2 by 2 again 0. 0 minus 1 by 2, so minus half, or let me write it as minus 0.5, and 1 minus 3 by 2, so 1 minus 1.5, this is also minus 0.5. Okay, now we have clear relations. Okay, now we have clear relations. Okay, what is that clear relation? Okay, if I have to again count the number of starting zeros, okay, now I will again count the number of starting zeros. We have used the letter M, I'll keep following the same. M is 0, how much is M here? 2. How much is M here? Again 2, so M is 2, M is 2. The M is 2, M is 2, correct? Okay, fine. The M is 2, but does it follow the increasing order? No. Same also not allowed. When the number of starting zeros strictly in the increasing order, then only I call it as a row echelon form. But now it is simple. R3 minus 0.5. Above one is 2.5. Okay, 2.5 divide by 5. It becomes 0.5, and then add. You will get zeros here. You will get zeros here as well. So R3 plus R2 divide by 5 plus R2 divide by 5. Correct? So on doing this much, what is the A I am getting now? Okay, what is the A I am getting now? Okay, the first row is same, 4, 2, 1, 3. Second row also I am not disturbing now, 0, 0, 2.5, 2.5, and then last row, anyways this is 0 and 0 plus 0. Okay, then these two also become 0. Okay, these two are also becoming 0. Now if you count the number of starting zeros here, okay, and again for a moment, let me move out of here. Okay, so how much is the starting zeros here? Nil. How much is the starting zero here? 2. How much is the starting zero here? 4. All 4 are 0. Okay, does it follow increasing order? Yes. Now this is clearly increasing, and there is a row of 0 also, which is at the last. Okay, so I can now say that this matrix is in row echelon form. And here, if a matrix is in row echelon form, then the rank is given by number of non-zero rows. Okay, how many non-zero row? First is non-zero, second is non-zero, third is entire 0 row. Okay, so how many non-zero rows? 2. How many non-zero rows? It is 2, dear. How many non-zero rows? It is 2. Perfect. Correct answer is 2. Okay, na? The correct answer is also equal to 2. That's what. Even in the dependency between the columns, we have discussed the same thing. Okay, when I discussed about the dependency, see here. What is there in the dependency? Where has that gone? Yeah. So there were two independent columns. Sorry, this one. There were 2 independent columns, and hence rank is equal to 2, and hence the rank is 2. Same thing we have figured out by which method? The echelon method. Converted the matrix into the row echelon form. Okay, just to explain you the echelon form again, I have taken it. Okay, right. And by chance, if the dependency of columns you cannot figure out, I am telling you, dependency is an easy method, time saving method, but there is a saturation limit to it. Okay, you try the dependency for 30-40 seconds, because sometimes dependency may be some complicated numbers, or sometimes dependency is not there. You are just wasting minutes and minutes to find dependency. So don't waste beyond 30-40 seconds. If there is a direct dependency, mostly you will find in 30-40 seconds. Otherwise, move forward. Go for determinant or row echelon calculation. Correct? Next question. Next question. Try this question. Come up with the answer here. Okay. So what is this question? Okay. V is a non-zero vector of size 3 cross 1. V is a non-zero vector of the size 3 cross 1, correct? Okay, V, non-zero vector of the size 3 cross 1, dimension 3 cross 1. Then the matrix A, VV transpose, has a rank of how much? Has a rank of how much? Then the matrix A, VV transpose, has a rank of how much? Figure out what can be the rank of VV transpose. What can be the rank of VV transpose? Now see here. Okay, let's try to solve it first. V is a non-zero vector of dimension 3 cross 1. What does it mean? Non-zero vector of the dimension 3 cross 1. What does it mean? Okay, let me take V as, okay, a non-zero vector means, suppose, 3 cross 1. Okay, so 3 rows and 1 column. Column vector. Okay. Non-zero vector. That means at least 1 out of x, y, z is non-zero. All of them cannot be 0, because if all x, y, z are 0, then the vector becomes 0. So it's a non-zero vector. Okay, so when I say non-zero vector, what do you mean by, what do I mean here is at least one of this x, y, z is not equal to 0. At least one of them is non-zero. At least one non-zero element is there. Okay. So what is the idea? What is the answer here? Okay. Correct. Rank is 1. So see, just for explanation, I am solving this question. Otherwise, I have already given the result. With respect to this matrix. Okay, with respect to VV transpose or something like that, I have already given you the result. Okay, I have already given you the result. Okay, so first, based out of the result. Okay, first, if I take the conclusion based out of the result, V is 3 cross 1. Okay, V is 3 cross 1. Okay, rank of V. What about the rank of V? If I want to talk about the rank of V, okay, it cannot be more than 1. It is minimum of M or N. Na? What is minimum? Minimum is 1. So rank of V less than equal to 1. Okay, but I am telling you V is a non-zero vector. At least 1 out of x, y, z is non-zero. That means rank of V will be 1. Okay, because at least you have a 1 cross 1 minor. Suppose x is non-zero. Okay, suppose x is non-zero. So you have a 1 cross 1 minor non-zero. Okay, so rank of V is actually 1. Because rank of V can be 0 if it is a null vector, if it is a null matrix, and it is clearly given to as a non-zero vector. The rank of V equal to 1. Dear, if rank of V is 1, firstly, okay, I can say that rank of V, okay, is equal to rank of V transpose, also equal to, I gave you some conclusion, na? Okay, it is also equal to rank of VV transpose, and that is what the question is. Okay, and also and eventually also rank of V transpose V. All of these are equal and equal to 1, equal to the rank of V. I told you one conclusion, straight answer is 1. Because rank of V is 1, rank of VV transpose will also be 1. Rank of V transpose V will be 1. Rank of V transpose alone also will be 1. Correct? Correct. Simple. Now, if you want to solve it in detail, okay, you multiply VV transpose. Then also you will understand. You multiply VV transpose. See, I'll just show you a rough calculation here. Okay, if you multiply VV transpose, let's say method number 2. Okay, let's say this is method number 2, and in that case, I will call this as simply method number 1. Okay, so what is there? Okay, if you try to multiply, just for one explanation, okay, what is the matrix A? VV transpose. Okay, what is the V? V is the column for me, X, Y, Z. And what is the V transpose? It is the row for me, X, Y, Z. Okay, so when I multiply, see how I'm going to form. Okay, X into X, X square, then XY, then X into Z. Okay, the first row, first column, first row, second column, first row, third column. This pattern is complete. Then next, what will I do? I'll start with second, Y into X, Y into Y, Y square. Then next will be Y into Z. Then next is ZX, ZY, Z into Z, Z square. Okay, now matrix rank is all about the minors, and minors is about determinant calculation. Okay, so in the determinant, what you can do is, okay, if you take X, Y, Z common, from where? X from the first row, Y from the second row, and Z from the third row. If you take X, Y, Z common, okay, 1 from each row. Okay, so first row X, Y, Z. Second row again Y common, so what is left? X, Y, Z. Third row again Z common, so what is left? X, Y, Z. All rows are actually identical. In the remaining determinant, okay, now you have the condition that R3 is R2 is R1. Okay, so I have only and only one independent row. I can say that I have only one independent row. And then you know, if there is one independent row, what is the rank? If there is one independent row, rank is also equal to the 1. What is there? Rank is also equal to 1. We have derived it, we have solved it. Okay, but as I told you, you can also take this as a direct conclusion. Rank of V is equal to rank of VV transpose, or rank of V transpose V, or rank of V transpose. All of them will be equal. Got it? Let me know for any doubts. Okay, next question. Gate 16, doubly 2 marks onto the same theme. Onto the same thing, you can tick mark then. You can tick mark and let me know the answer. Come on. You can tick mark and let me know the answer. Come on all. Yeah, come on. Okay, so A be a 4x3 real matrix with the rank 2. Okay, what is given? Rank of A is equal to 2. So what can I say? See, options are about rank of A transpose. Okay, rank of A transpose. Yeah, direct question, rank of A transpose. Okay, so rank of A is 2 and same will be the rank of A transpose. Okay, and that is simply equal to 2. Option number B. Not less than 2, not greater than 2. It is equal to rank of A. B, straight tick mark question. 2 marks, tick mark question. It's not about deriving it, it's about some standard results that I have already concluded in the beginning. Yes, Saurav Kumar, Vardhan, Sai Vikas, Akshay Kumar. Correct, it is the option number B. Anyways, option number B. Okay, moving ahead towards the next question. Yeah, the rank of the matrix given below is 1. Okay, what type of matrix it is? It is a 3 x 2, 3 rows and 2 columns. Given the rank is 1, not even 2. What is the ratio alpha by beta? Come on, you can do it. What is that ratio alpha by beta? Gate IN 2 mark question 2023. The rank of the matrix given below is 1. What is the ratio alpha by beta? Come on. What is that ratio alpha by beta? Rank is 1, not even equal to 2. Okay. So now see, if I directly convert this, Okay, if I say the rank is 1, I can say that very simple method. Okay, no need to convert to row echelon form. One thing is you can convert to row echelon form. Another thing is rank is 1. Okay, that means minus, which minus 2 cross 2 minus also, 2 cross 2 minus also are all 0. Correct na? Because if there is 1 2 cross 2 minor which is non-zero, rank should be 2. Rank should be 2. Okay, Saurav Kumar has the answer already. So yeah, so if I take 1 2 cross 2 minor here, 1 4 minus 3 and alpha, this has the alpha in it. Okay, this has the alpha in it. Actually, not only ratio, you can directly find alpha and beta individual value also. Okay, Naresh has the answer 8, Saurav has the answer minus 8. Okay, so this tells you that alpha minus plus 12 is 0, and hence alpha is minus 12. Finish. Alpha is minus 12. Now take the first row and the third row. Form this 2 cross 2 minor, because to form 2 cross 2 minor, any row can be deleted. Now one row is extra. So 1 4 beta 6. This also has to be 0. Okay, and this means that 6 minus 4 beta is 0. So what is the value of beta? 6 by 4, or beta is 3 by 2, 1.5. Okay, so what is that ratio alpha by beta? Come on, what is that ratio alpha by beta? It is equal to minus 12 divided by 3 by 2. So 2 goes above, 24 by 3, 8, minus 8. Answer would be minus 8. Minus 8, minus 8, minus 8. Correct answer, Saurav Kumar. Sai Vikas. Correct. It is minus 8. Simple idea. Rank is 1, so even all 2 cross 2 minors are all 0. Correct. Logical question. See, that is what the basic fundas, if clear, na, are able to handle the 2-mark question also. Next question. Next question. Okay, GATE 2025 instrumentation 1-mark question. The current year 2025. Yes, Naresh, negative 8 it is. Rest all okay, it is negative 8. A 2n cross 2n matrix A has its elements given by, has its elements as aij equal to minus beta, I plus j equal to even, and it will be plus beta if I plus j equal to odd. A 2n cross 2n matrix. Okay, right. Where n is any integer greater than 2 and beta is a non-real. Beta is any non-zero real number, not non-real, I'm sorry, non-zero real number. Okay, n is any integer greater than 2, n is greater than 2, and beta is a real number, non-zero. That is what is given. What can be the rank of this matrix? Try to form the matrix. Now let's try n equal to 3 for example. Okay, if you try with n equal to 3, what is the matrix you will form? See here. Okay, what is the matrix you will form? Okay, if I try with n equal to 3, the size of the matrix will be how much? 2n cross 2n, 6 cross 6. Okay, 6 cross 6. Let us see how the matrix will look like. Dear, if you just make the matrix once, now your answer will be there in front of your eyes. It is just about understanding, reading the question, attempting it. You try to form the matrix, answer is in front of your eyes. I'll just show you how the answer is in front of your eyes. See, okay, if I plus j is even, you take minus beta. Okay, so what is the first element you start with? What is the first element? Here you will write a 1 1. So what is 1 plus 1? 2. 1 plus 1 2. 2 means even. 2 means even, and even means write down minus beta. Okay, then alternate na. 1 1 1 2. 1 plus 2 is odd. Then 1 plus 3 is even. That will alternate anyways. Any doubt, please let me know. Okay, so minus beta plus beta, then minus beta plus beta, then minus beta plus beta, up to 6 terms because I have 6 columns. Now next row. What do you write in the next row? A 2 1. 2 plus 1 is odd. See, above 1 was 1 1. If 1 1 is even, next anyways will be odd. Okay, 1 plus 1 was 2, 2 plus 1 is 3. And odd means what is the beta to be taken? What is the value to be taken? Plus beta. Okay, and then again next will be minus beta, then plus beta, then minus beta, plus beta, up to 6 rows. We are up to the 6th number of rows. Sorry. Yeah. Minus beta plus beta, minus beta plus beta, minus beta, and again plus beta. Correct? 6 rows. Okay, and then here if the any row starts with beta, the next element is going to be the minus beta. Beta, minus beta, beta, minus beta. Okay, then here minus beta plus beta, minus beta plus beta, minus beta plus beta, then beta, minus beta, beta, minus beta, beta, minus beta, minus beta plus beta, minus beta plus beta, minus beta plus beta, last is beta minus beta, again alternate beta minus beta, beta minus beta. Okay, every alternate row is same or not? Every alternate row is same or not? Okay, so Saurav and Sai Vikas has some answer. Yes, every alternate row is same or not? You just see. Correct. Okay, so R3 is equal to R5. R5 I'll say R5 is equal to R3 is equal to R1, and also R4 is equal to R2 is equal to R6 is equal to R6, second, fourth and sixth row. But not only this, what is the relation between R2 and R1? Only a minus sign difference. Okay, every element just sign opposite. So I can call this as minus R1. I can call this as minus of, just a second, this is R6, R4 and minus of R1. Correct. So all rows are dependent. Just a second, what is happening here? Basically all rows are dependent, and here if all rows are dependent, okay, only one independent row. Okay, which one independent row? First. You have only one independent row, and hence I will say that the rank is simply 1. Only one independent row, and hence I will say that the rank is equal to the 1. Hence I will say that the rank equal to 1. Correct na? Okay, correct. So next question then. Let's move ahead to the next question then. All right. Rank equal to 1. Option number A. Rank is directly equal to 1. Okay. It was just about forming the matrix by the nature of the given elements. That's it. And tried the minimum n. They told n is any value greater than 2. I just tried 3. Enough. Okay. Enough. That is enough. We get the conclusion. 1. Yes, to Saurav Kumar, Sai Vikas. Okay. Correct answer. Right. Next question. See this question. Gate 25 EC 1 mark question. Okay. A 4 cross 4 matrix is given in front of you. Right. Okay. For which of the following combinations of alpha, beta and gamma is the rank of the matrix at least 3? The rank of the matrix at least 3. Like alpha 0, beta gamma not equal to 0. Beta and gamma not equal to 0. Rank you want at least 3. But if alpha 0, what will happen? Okay. We can from actually, I'll just show you, one by one what is the case that you can apply. What is the case you can apply? Okay. See dear, if you count with the number of starting 0, let me, if I assume alpha, beta, gamma are all non-zero, if I assume that all are non-zero, okay, so then how many starting zeros? 1, 2 and 3. Okay, row echelon form can be achieved. Row echelon form can be achieved. Okay, number of starting zeros, okay, this is nil, okay, this is m equal to 1, this is m equal to 2, this is m equal to 3. Row echelon form can be seen. Okay, can be seen. Okay, but yeah, if alpha also 0, then these two may become same. Okay, these two become same. So that's what we have to figure out. You want the rank at least 3. You want the rank of the matrix at least 3. Okay, at least 3. Now see, very clearly I am telling you, if alpha, beta, gamma all are non-zero, whether they are equal or not equal, that does not matter. Okay, if you take any value of alpha, beta, gamma all non-zero, I'll just move slightly away here, just a second. Understand this. If alpha, beta, gamma all are non-zero, okay, then definitely, okay, you have the row echelon form. Okay, and the rank is number of non-zero rows. Okay, gamma is also non-zero, alpha, beta non-zero, so every row is actually non-zero. every row is actually non-zero. The rank will be 4. Okay, and yes, you want the rank to be 3, at least 3 or more than 3. Okay, next situation may be, you take alpha equal to 0. Okay, alpha equal to 0, beta gamma not equal to 0. Beta gamma may be equal, maybe not equal, that is not important. Okay, but if alpha equal to 0, then dear, this value will change. If alpha is 0, you extend one more 0 here. Okay, then you get m is equal to 3. Here also 3. 3 and 3 same. You will have same. Okay, and same means it is not going to be in the row echelon form. But beta and alpha can be related, and if you relate beta and alpha, okay, you can say that the fourth row is dependent on the third row. Okay, but at least 3 non-zero rows. At least 3 non-zero rows. Correct, na? At least 3 non-zero rows. Any doubt, you tell me here. Okay, 3 non-zero rows will be there, right? Okay, 3 non-zero rows. Or rather, okay, we'll discuss more about this. Forget this. If I at least take the reverse. Okay, if alpha not equal to 0. Okay, if alpha not equal to 0. Okay, then whether gamma is 0 or non-zero. Okay, alpha not equal to 0, then what about beta? Does not matter. Okay, you will have only 2 starting zeros here. If alpha is non-zero, okay, 2 starting zeros here, and gamma may be 0, may not be 0. Okay, gamma may be 0, may not be 0. What is the only difference going to come? See, alpha not equal to 0, maybe gamma also not equal to 0. Okay, then this m equal to 3 will follow. M equal to 3 will follow. Okay, all rows, gamma also not 0, so all rows are non-zero, rank will be equal to 4. Okay, but if alpha not equal to 0 and gamma equal to 0, okay, gamma equal to 0, then what will happen? If gamma is 0, then you will have m equal to 4 here, but still that is increasing form only. Okay, but because gamma equal to 0, the fourth row is 0. How many non-zero rows? Okay, 3 non-zero rows, rank equal to 3. Okay, that is also okay. I want rank 3 or more. Okay, I want rank 3 or more. Okay, so see, definitely if alpha, beta, gamma not equal to 0, all them may be equal. I say they are equal or not equal does not matter, but if they are non-zero, okay, here the rank is 4, correct? This is to be counted. Then I told you alpha not equal to 0. Okay, this is also to be counted. Alpha not equal to 0. Okay, but gamma is 0. Alpha not equal to 0, gamma is 0, beta will be don't care actually. Okay, so rank will be 3. Okay, alpha equal to 0, gamma equal to 0. Okay, alpha and gamma equal to 0. Yeah, this is what I have left. I will discuss this. Alpha also 0, and again alpha equal to 0. Now see, what I am trying to tell you, if alpha equal to 0, then this particular value, I will stretch it here, this particular value m will become how much? 3. If alpha also, you see here, if you take alpha 0, then what happens? This also will have 3 non-zero rows. Okay, this also will have 3 non-zero rows. Okay, so now if alpha equal to 0, now next condition is beta and gamma also 0. Beta and gamma also equal to 0. Okay, so alpha 0, beta 0, gamma 0, two row of zeros. Okay, so how many non-zero rows? 2 non-zero rows. Okay, 2 non-zero rows. Okay, but if alpha equal to 0, okay, but beta and gamma are not 0, they may be equal or unequal. Okay, but beta and gamma non-equal to 0. Using elementary operation you can convert gamma to 0. Okay, but beta still will be non-zero. Beta non-zero means 3 rows non-zero. Okay, and rank here will be 3. Okay, so now you see, alpha equal to 0, beta gamma not equal to 0, rank will be 3. Okay, but alpha equal to 0, beta gamma also 0 will give you rank equal to 2. Okay, so what is to be taken? Okay, first, third and fourth, option number A. First, third and fourth will ensure that the rank of the matrix is at least 3. This question, just a second, yeah. This question I have solved purely on the analysis of the row echelon form. Think about this, okay, take your time. I have given you sufficient hints, okay. So you just try to solve this question once again. All conditions I have written in front of you. Okay, I'll share you the PDF in my Telegram group, don't worry. Okay, but try to analyze this question again and see, okay, whether you have got it or not. Okay, try to reattempt this question. Concept, at least again the row echelon concept will be opened by this. Okay, few questions we have solved today by row echelon, few we have solved by determinant, few we have solved by the dependency between rows and columns. Correct? Chalo. All right, let's move ahead then. Let's move ahead. 2 homeworks for you for tonight. Okay, please do solve the homework and mention in the comment box of the video. Not now, not right now, not in the live chat box. Solve it. Mention your answer in the comment box. I will reply whether the answer is correct or not. What is the rank of this matrix? 5 cross 5. 5 cross 5. But since it is a 1 mark question, it should not be that tedious. Think how you can approach to this. Okay, a 5 cross 5. Okay, GATE 2017 easy 1 mark question. And another homework number 2. Giving you 2 homeworks for the day. Okay, GATE 2018 civil 2 mark question. Okay, based on again a 3 cross 4, like we have already solved a 3 cross 4 question today. This is your homework number 2. I request you to solve this and place your answer in the comment box of the video. Okay, solve it, take your time and place it in the comment box later on, and I will reply whether answers are correct or not correct. All right. Okay. So yeah, hope you enjoyed and hope you learned from this session. And if you really learned, okay, do not forget to hit the like button. Do like the video on the YouTube, and I will bring you the next video, okay, on linear algebra only, where we'll talk about linear system of equation. Again, we'll try to explore and learn the topic through PYQs. Okay, right. So yeah, that's what. Some important information for you. The next offline batches, okay, if you want to come in a competitive atmosphere among hundreds of students and majorly in front, you know, straight direct in front of the best ECEE faculty team, yes, so you can enroll for our offline courses, which is available at Hyderabad. Okay, the fee 65,999 is currently priced at 54,999. Okay, and the new batches for EE starts 31st of July, and for EC it starts 10th of August. Okay, for EC the next batch starts 10th of August, for EE 31st of July, and there are some special discounts, of course, which are mentioned in front of you. Okay, so for any more queries you can contact 95156944053 and get all your doubts rectified. Okay, but yeah, if you want to really prepare for GATE, but by any chance you cannot travel to Hyderabad for offline for some reason, maybe you are college going student, or for some reason you can't come to Hyderabad for offline, you can still get the same content by the same faculty team, the best faculty team for ECEE, through our online live course. Yes, the GATE for online live course, GATE 26 and GATE 27, both modules are available respectively 1 year and 2 year. Okay, with the fee of 19,999 for 1 year, for 2 year it is 28,999. Okay, so you can also enroll for our online live course. Okay, available for EC and EE both, right? And if you're preparing for the state AE examinations, okay, like Transco and Discoms for AP, for Telangana, okay, as you know, notifications are expected this year, huge number of vacancies are going to come up. So for those willing to prepare for AE, the offline batches, okay, at our Hyderabad center, the new offline batch for AE starts 4th of August. Yes, the Monday, 4th of August, right? Chalo. So I will share you this particular PDF in my Telegram group. Okay, if you are not connected in my Telegram, okay, you can join using the link mentioned. I have given the name of the link, okay, name of the Telegram group. Okay, you can join it and I'll share you the PDF, okay, tonight or possibly by tomorrow as well. Okay, by tonight or tomorrow I'll share you the PDF, but all the PDF that I share are password protected for a simple reason. Okay, those who have watched the session, those who have actually followed the session, they only need the notes, they only can understand the notes. Okay, so and if you are already following the video, you will get to know the password as well. So password, it's a randomly created password. Okay, what is the password I should create for today? What is the password I should create for today? Okay, let's keep it simple. Let's keep it simple. It is the rank only as per the topic, as per the today's topic, everything in small. Everything is small, RANK. The password, okay, for the today's PDF will be rank, RANK. Okay, that's it guys. Thank you for joining Home Institute, and if you want to attend all the session without a miss, do not forget to subscribe to the channel in case if you are not subscribed. Okay, bye bye, thank you, good night, stay safe, see you in another session where I'll talk about linear system.